Okay, this is a video I would love for you to watch the entire thing, especially with this tangent stuff right there. There's some things that I have from my work that I have posted that I'm going to do a little bit differently because if it's free response and there's a couple different answers you can get, I can give you credit for each one and I can give you partial credit, right? But if it's multiple choice, there's a certain way that I'm going to work out for you. I'm going to work it out exactly the way I need you to work this out. But since it's multiple choice, there's a certain particular way I need you to approach these that's different from what I have posted for my work there, okay? Now, part of this is going to be easy. The sine formula is easy. Drawing your triangle, you guys are all been perfect at drawing triangles ever since like January, okay? So we're going to be good with most of this problem. What we need to work at though is this tangent stuff. Also, what we need to add in is a quadrant. It's also going to ask us what quadrant does the alpha plus beta lie in. And so I'm going to review with you how to do that. What I like you to add that to your homework, okay? Now, when you are working with the formulas, this is your addition subtraction formulas, and I got all the formulas right there for you. You can get all of them right there. And then from your reference sheet, the couple that we got to be careful on is the sine of alpha plus beta and the tangent of alpha plus beta. So that's just your sine, cosine, cosine, sine problem. If it's a sine problem, the signs are going to match. So if that's a plus, that's a plus. And then the tangent, it just goes tan, tan, 1 minus tan, tan. And then these signs always match on the top. And then that's always opposite on the bottom right there. But you have those in your reference sheet and then my work there. And we're going to have them right now, right? So what you need to do when you see alpha plus beta, the good news is it told us that alpha and beta both lie in the second quadrant. So which means I'm going to draw 2 triangles in the second quadrant, one for angle alpha, one for angle beta. And what I would like for you to do, just like we did before, is I would like for you to do your legwork right here, which means I want you to find the sine, cosine, and tangent of those triangles, of those angles. And I want you to do your signs here according to your all Snickers taste chocolatey, right? So use SOHCAHTOA. If I tell you the cosine is -4/7, remember SOHCAHTOA, cosine is the adjacent side over the hypotenuse. And then you can go 49 minus the 16 here to get, this is going to be radical 33. And remember, I always label my triangle with positive sides. If you want to throw the negatives in there, you can. Just be careful with that. But I always use positives for everything. And then when I go down here, as long as I remember to do my all Snickers taste chocolatey, I'm going to have my correct signs on this thing. So we're going to be good. Now, when you see cosecant of beta is equal to 2, that's the same thing as 2/1. That's the same thing as sine of beta is equal to 1/2. Remember, sine and cosecant are reciprocals of each other, and I like the sine function better than I like that cosecant one. It's a little bit easier to work with. So if cosine is 2/1, sine is 1/2, and if sine is 1/2, that's going to be, sine of beta is 1/2, so that's this separate triangle. That's going to be opposite over hypotenuse, and I can go 4 minus 1 to get the square root of 3 right there. So let's use SOHCAHTOA real quick, get the legwork done. So sine is going to be opposite over hypotenuse, cosine is going to be adjacent over hypotenuse, and tangent is going to be opposite over adjacent. And I'm going to use my all Snickers taste chocolatey. Since I'm in quadrant 2, sine is positive, that one's done, but the cosine and tangent are both going to be negative. So you got to squeeze those in right there. That way when I get to the formulas, I don't have to worry about those anymore. And then the same thing here. So sine is going to be opposite over hypotenuse, cosine is adjacent over hypotenuse, and then tangent is opposite over adjacent. Now, here's what I would like for you to do for this multiple choice is leave that radical 3 on the bottom. Don't rationalize it. There is a way you could do it if you rationalize it that my work has, but then you don't get the answer choice that we got for the answer choice, right? So just leave that radical in the denominator, and I'll show you exactly how I need you to work this out. And that's for these whole problems, just for the sine, cosine, and tangent of alpha plus beta formulas there. Now, when, and then remember, cosine is negative, and then tangent is negative. So don't rationalize that, leave that alone. Now, when you go to your formulas, sine of alpha plus beta is going to be sine, it's just your sine, cosine, cosine, sine pattern. So it's going to be sine alpha cosine beta plus cosine alpha sine beta. So there's my sine, cosine, cosine, sine. And since I already did the legwork, this is a real easy problem. All I got to do is insert those into their proper spot. So the sine of alpha is our radical 33/7. Cosine of beta is negative radical 3/2. Cosine of alpha is -4/7. Sine of beta is the 1/2. And then so you're going to get 3 times 33. Now what that turns out to be is square root of 99. All right, you can multiply those numbers together, but then 99, you can make that 3 times 11. I'm sorry, it's 9 times 11. And so when you break it up, it's the square root of 9 times the square root of 11, which is 3 radical 11. So I do want you to simplify those perfect squares if you can. And then you have a positive times a negative, which is a negative. So you're going to get negative 3 radical 11 right here. And then this is just going to be your minus 4. And then you have 7 times 2 to get a 14 on the bottom. So there's your final answer for that sign part. Okay, so the sign is not going to be our issue. That's going to be pretty good for us. What I'm a little concerned about is the tangent problem right here. So let's get into it. I will do this thing all the way through from scratch. So your formula, from your formula sheet, or from your old stuff, wherever you have that at. So you're going to go tan alpha plus tan beta over 1 minus tan alpha tan beta. There's our formula. So I'm going to get that down first. Tan alpha tan beta. All right, and then I'm just going to plug in these numbers here. And it's going to look messy, but I got a way to simplify it for you there. So tan alpha is our negative radical 33 over 4. And then tangent of beta is the negative 1 over radical 33. I'm sorry, the negative 1 over radical 3. And on the bottom, you have 1 minus, and then the same thing. Tan alpha is negative radical 33 over 4. Tan beta is a negative 1 over radical 3. So I'm going to simplify this a little bit. If you have plus a negative, that's the same thing as just minusing it. So I'm going to minus 1 over radical 3. And on the bottom, you have 1 minus. So since I have a negative times a negative, that'll just make that thing positive. So I have a positive radical 33 over this 4 radical 3. Now, here's one option. If you're doing like a free response for future years, free response, we got to keep going. We got to get this exact value right here. If you are having trouble with the rest of this problem, one option right here is to take all this stuff, plug it all into the calculator. Maybe plug the top part in, hit equals, write it down. Plug in the bottom, hit equals, write it down. Divide those numbers, get a decimal answer for this. Then you could take the answer choices, plug the answer choices into the calculator and see which one gives you the same decimal answer, right? So that's one option that you have if you get stuck with the rest of this, but just pay attention to the rest. I'll show you how to get the exact answer here. But you got to make sure you know that formula. You got to have your legwork. You got to insert those into the formula properly. And here's what we're going to do to get rid of the complex fractions. This is a complex fraction because you have a mini fraction inside of a mini fractions inside of a larger fraction. So what I showed you in the past, that little trick, is you look at all of your mini fractions and you look at the bottoms, and you look at what's down there. So you have a 4 and a square root of 3, you have a 4 and a square root of 3. That's your magic number that you're gonna multiply the top and the bottom by. So I'm gonna multiply the top and the bottom by the 4 radical 3. And so right now I'm just gonna ignore the bottom. And I'm gonna take this egg-shaped thing, times it by 4 radical 3. You see how the 4s are going to cancel? But I'm left with negative radical 33 times radical 3. Now negative radical 33 times radical 3 is a negative square root of 99, and we broke that down over here where we said that was 3 radical 11. So I'm going to write down negative 3 radical 11. And then now when I take this egg-shaped thing times this, the square root of 3's cancel, but you have 1 times 4, which is a 4. And on the bottom, you have 1 times, so you're ignoring everything up top. So you're going to go 1 times a 4 radical 3 to get a 4 radical 3 there. And then you take this times this, the 4 radical 3's cancel, and you're just left with the square root of 33. So when I'm telling you a couple things there that's different from the work that I have posted in my work packet is right here, leave the radical in the bottom, right? And then just put that in there and then do the complex fraction like that, and then we'll get the same answer. Now, if you did happen to accidentally rationalize that and then use that number instead, you're going to get a different looking answer. But trust me, these answers are the same if we plug them both into the actual calculator. Now, if you did happen to do that and you got some crazy answer that was different from the choices, again, you could plug the stuff into the calculator and then you could plug the choices into the calculator and see which one gives you that decimal approximation. But the exact value, the answer choice that'll be there is this guy right here. Now, the last part of this, we're not done yet. So that's 2 problems. What they're also going to ask us is what quadrant alpha plus beta lies in. Now that does not on your worksheet, but I'm asking you to add that in. the quadrant that alpha beta lies in. Think about if alpha and beta are both in quadrant 2 and you add them up, that means the sum is not going to be in quadrant 2, right? If you have like a 150-degree angle and then you have like a 95-degree angle and you add those up, we might be in quadrant 3, we might be in quadrant 4. Sometimes they go all the way around, be pretty large, and possibly end up in quadrant 1 or something like that. So it's not going to be in quadrant 2 anymore if you're adding up two angles in quadrant 2. And so this stuff is actually the easiest part of the problem here. You did these before, you just don't realize it. What I want you to do when you have to figure out what quadrant it lies in is figure out whether this sine answer is positive or negative. Figure out whether this tangent answer is positive or negative. And then I'm going to show you that little trick that we did before. So what we did in the past, well, first of all, I just plug all that into the calculator. When you plug all this into the calculator, you're going to get a negative number. Try that. Make sure you can do that. When you plug all this into the calculator, you're also going to get a negative number. So when I'm trying to figure out the quadrant I'm supposed to use, I just said that the sine was negative. Now remember, if I say sine is negative, we're telling you sine is less than 0. And if I say tangent is negative, we're also saying tangent is less than 0. We had this for like several chapters in a row. This is where you just write down your quadrants. All you are utilizing is your all Snickers taste chocolatey. And then remember, if your sine is negative, positive in 1 and 2, which means your sine is negative in quadrants 3 and 4. So I jot those quadrants down. And if your tangent is positive, it's 1 and 3. But if your tangent is negative, that means you're talking quadrant 2 and quadrant 4. And so your winning quadrant is quadrant 4. So that's your answer right there. The last part, I'm going to work out this entire thing because I realize that it's been a long time since we've done these, and these are some of the tougher problems right here. So I apologize for the video being too long, but I also thank you for paying attention to all this stuff there, okay? This one I have a lot of it filled in for us already just to try and make this a little smoother, but it tells us this is for parts like C and D there. It gives us sine of alpha and secant of beta. And then I made a triangle for alpha, triangle for beta. When it gave me sine was 5/8, I did opposite over hypotenuse. I did my Pythagorean theorem to figure out the other side. I did my sine, cosine, and tangent just using SOHCAHTOA, and I realized that the cosine and tangent were negative in quadrant 2, but the sine was positive. And when I saw secant of beta was -4/1, that means cosine of beta is equal to a -1/4. And I did adjacent over hypotenuse. That's how I got the 1/4 there. Did my Pythagorean theorem, did the sine, cosine, and tangent, did my leg work right there. All right, so you guys are all good at that. So practice that, be perfect with your triangles, get the leg work down. This sine problem should be really simple for us. So when you see the sine of alpha plus beta, that's just your sine, cosine, cosine, sine pattern. And then you just take all those numbers that you just found, insert those into the parentheses, and then I had 39 and 15 inside the radical. So I multiply those together to get radical 585. And so then that's a large number, all right? Just divide it by, start dividing it by the perfect square. Some of your calculators will reduce that for you already and you don't have to worry about it, but some of you might not. So then just divide it by 4, divide it by 9, divide it by 16, 25, and see which perfect square actually goes into that, if any. And then, so that's 9 times 65, and the square root of 9 is equal to 3. And then if you do get some large numbers and you have trouble simplifying that, like I said, you could plug this into the calculator, plug the answer choices into the calculator, and see which ones are giving you the same thing right there, okay? But when you're plugging stuff into the calculator like that, put in all the numerator, hit equals, or put the whole numerator in parentheses, hit the whole denominator in parentheses, you know, get a number for the top, a number for the bottom, you know, and then just divide those right there. All right, so let's do the tangent from scratch. I didn't want to fill that one out. I feel it'd be beneficial for us to see this one from scratch. So thanks for staying with me here. So tan alpha is -5 over radical 39, and then plus tangent of beta. So instead of putting plus and negative, I'm just going to write that as minus radical 15. And on the bottom, we have 1 minus. Now, when I do tan alpha, tan beta, that part's going to be -5 radical 39. And then you're times it by the tan beta, which is negative radical 15. This looks funky, all right? But we could handle this, all right? Just stay focused here. When I have a negative times a negative, that's going to be a positive number right there, right? So this 1 minus was already there. That carried down. And since I have a negative times a negative, that's just going to be a positive number right there. And then you have 5. You're just smushing those together. You have 5 radical 15 over radical 39. I know that looks funky, but we could handle that, right? So just smush it together. And again, if you're having trouble with the rest of it, put the top part in the calculator hit equals, put the bottom part of the calculator hit equals, divide those two numbers, take the answer choices that we give you, and then plug those in the calculator and see which one gives you that same answer choice right there. But you guys are smart enough too. We could get this complex fraction. This one's actually a little bit easier than the first one we did, because when you look at the mini fractions, there's only one thing in the bottom, that's the radical 39. So what we're going to do is we're going to multiply the top and the bottom by the radical 39. So when I take this times this, see, the radical 39s will cancel, and you have the -5 left still. And then right here I have 15 times 39. I don't know what that is, so I'm just going to go 15 times 39. I already had it in there. That's going to be 585. So I get the square root of 585. Now on the bottom, you have 1 times the square root of 39, which is square root of 39. And this here, you're taking this times this, the radical 39s are going to cancel out. And we're going to have the 5 radical 15. And the only thing is, like, 39 is just 13 times 3. 15 is just 5 times 3. There's nothing you could do with that. And the 585, we said that was 9 times 65. And so you can rewrite that as 3 radical 65. And there's the answer that we're looking for there. So for multiple choice, we need to get this answer. We need to get this answer, or it plugs up into the calculator. For free response for future years, I'll accept these answers here, and I'll also accept these answers that I have with my post at work. With my post at work, I actually rationalized it and actually used the -5 radical 39 over 39. Then I was able to kind of just simplify it the same way, get rid of the complex fractions, and the answers look completely different there. So on a free response for future years, I will accept this answer here, or I accept this answer right here. So more than one thing, but multiple choice, we got to be able to get this or practice those decimal approximations. Now, what I'm going to do, the last part of this, we have to decide what quadrant the alpha plus beta lies in. So to do that, you're going to plug this into the calculator and determine whether this is positive or negative. And it turns out that that's going to be a negative number. And then you're going to plug this into the calculator, determine whether that's positive or negative. Turns out that that's a positive number. So then I'm going to kind of write that down. So if I know that the sign is negative, that means sign is less than 0. If tangent is positive, that means tangent is greater than 0. Now I'm going to use my all Snickers taste chocolate. If sign is negative, I know sign is negative in quadrants 3 and 4. And if tangent is positive, that's going to be in quadrants 1 and 3. Or some of you in the past, you did a little shady thingy. You know, you continue to do that, whatever you did before. And then your winning quadrant, though, is that quadrant 3. So please practice those. You are all smart enough to handle that stuff there. It's a lengthy problem, but try not to confuse the lengthiness of the problem with the difficultiness of the problem there. I do think the tangent stuff is pretty involved, okay? But I know you're smart enough to handle that there. You guys have proven to me that you did that complex fraction trick, before, so we can handle doing that. But we got to practice those more than once. We got to practice a bunch, so we're perfect with that, so we can get those right in a multiple choice situation. Just be perfect with that. Thanks for paying attention to that. Appreciate it. Work on them.